Dear student, let us see this question, regarded as one of the difficult question in the exam. So what does it say? It says that the water tank is shown in the figure. So this is, imagine this is the water tank. Now let us visualize what it's trying to say. It has one wall at x equal to L. So this is one wall. Then it can be taken to be very wide. You consider this to be very wide. Okay, in the z direction, you consider it to be very wide. Okay, so what is the important thing to note here is what you regularly study usually is a meniscus which is considered to be spherical. But here the meniscus, imagine the meniscus will not be spherical and it is elongated in z direction, right? So our normal formula may not work. Now let us see what is given. Can be taken to be very wide in z direction. When filled with liquid of surface tension S, so this is the value of surface tension, density. Liquid surface makes angle theta naught very less than 1. So we can consider it to be small, and so for a small angle, you know this approximation, right? But they have explicitly mentioned here, no problem. So sine theta is can be considered as good as theta, as good as tan theta. And that is our dy by dx. So what is asked here is, if yx is the height of the surface, so this yx is the height of the surface, everywhere as a function of x, how it will come. Okay, so the yx, the height of the surface, then the equation of yx is means y as a function of x. So at different value of x, there will be different value of y. That is what we have to find a relation to it. As you can see the option, we don't have to solve this, we just have to generate a differential equation for this. Now what is not to be applied? Okay, so if the surface is curved along one surface and it is spherical, we know the pressure here and pressure here. The difference of the pressure is given by, if there is only one surface and one liquid and like our water drop. So it will be 2T by R, right? But this formula will not be applicable here. It is not spherical. Okay. So the surface is little different. Okay. So surface would be like, this is the surface. So one side, there is a wall and then we have this. This is how the surface would look like. So it would look like something like this, but not spherical. Now, what is the formula then? Okay, so this is what you need to know about if the surface is bent on one side, curved on one side, the value of excess pressure, is given by S into d2y by dx. Okay, and what is excess pressure equal to? So the excess pressure at any point like around here to here, it will be related to this y. Outside it is P naught and inside it will be like, little less than P naught by rho g y. So excess pressure will be given by rho g y as usual. Okay, so you just have to put it here, just replace it. You will get d2y by dx2 delta P, you can write it as rho g y, and then S you divide, so rho g y by S. Okay, so that's how your answer will come as second question. Okay.